In this video, I'll be discussing pathway mixes in Greek.net. You may have seen a mix used in a process or pathway before, but may not have known its purpose. So by the end of this video, you should have a good idea of what a mix is and how to use them in Greek.net. I'll start by describing mixes and their features, then I'll demonstrate how to edit and use them. As you may have read in the Greek manual, a pathway mix allows a user to define how multiple pathways are used together to form the source for a product. Weighted shares of each production pathway are specified to define the proportion of each pathway that contributes to the making of the product. One example is biomass for ethanol. There are multiple biomass feedstocks that could be used to produce ethanol. With a mix, I could include ethanol made from forest residue, or ethanol made from corn stover, or any type of ethanol from biomass pathway to define the composition of the ethanol in my process. Mixes can be identified in the Greek viewer by their peach color. To examine or edit a mix, simply click on it just as you would with a process, and an editor window will open. If you're interested in a specific mix, you can click on Pathway Mix in the Data Editor's pane menu and search for the mix. Keep in mind that mixes are used when all of the combined resources are the same. Mixes should not be used to create blends of dissimilar resources. For example, when blending ethanol and gasoline to produce E10. In that case, a process should be used and not a mix. There are three main areas in the mix editor. The first is the main frame at the center with a pie chart showing the composition of the selected pathway mix. To the right of the pie chart is a list containing the pathways included in the mix, and each pathway is hyperlinked so that you can open the pathway in a separate editor window. In this frame, you can view and/or specify the percent shares of all the pathways contributing to the mix. Then the percent shares will be reflected in the pie chart. I should note that shares can be represented as a function of mass, energy, or volume. This is particularly important for fluids, which can be represented by volume or energy, so you'll have to specify your preference. And I'll show you how to do that in just a moment. There are two buttons to the right of each percentage field. The Chart button is used to edit the time series of each pathway in the list of included pathways, and the X button will delete a pathway from the list. If you click the button at the bottom of the pathway list, a bar chart appears to show another graphical representation of the percent shares of each pathway. The second area is the frame at the left that contains compatible mixes and pathways that can be combined into the mix. These are all the pathways and pathway mixes that can be dragged and dropped into the pathway mix in the main frame, and they're grouped into pathway mixes and pathways within the output resource. The third area of the mix editor is below the main frame, and it contains some of the standard editor window features we've seen before. Here's where you must specify whether the shares are defined relative to energy, mass, or volume of the resource. There's also a feature that allows you to create your own upstream input for a product. For example, if you're using average values, in which case a fixed mix can be created by selecting fixed instead of calculated. Then you would have to manually add the resources and emissions per specified product amount, though this feature isn't often used. Now that you have some understanding of pathway mixes and the features of the pathway mix editor, I'll demonstrate how to modify a mix and then check its results. I'll go to the Data Editor's pane and click Pathway Mix, then search for an electricity mix. The mix I'll choose for this example is called Non-Distributed US Mix. In this mix, there are 10 pathways. I can see that power generation from coal, natural gas, and nuclear make up about 85% of the mix. Now, I previously downloaded some data from the U.S. Energy Information Administration because I want to make a mix that represents electricity generated in the state of Illinois. And I can just edit the US mix here to reflect the percent shares that I calculated from my downloaded data. I'll keep power generation from oil, coal, natural gas, nuclear, and hydroelectric, and delete the rest of the pathways. I now want to add in a pathway called non-distributed other power generation plants without hydro. The data I have lists other renewables without specifying any detail, but if I knew which renewables were included here, I could modify the other power generation plants pathway to reflect those renewables. Next, I'll fill in the share percentages. Then I want to rename this pathway Illinois Mix and click Add as New. Finally, I'll recalculate the model in order to make my new mix available. Now the mix is ready to be used in a pathway. I'll go to the WTP pane and select my new mix to view the CO2 emissions result. Looks like the Illinois mix results in about 90 grams of CO2 emitted per megajoule of electricity generated. For comparison, I'll select the US mix that I started with. And here there are about 140 grams of CO2 emitted per megajoule of electricity generated, about 50 grams more than my Illinois mix. Probably the biggest factor there is that the US mix has about 20% of generation coming from nuclear power, whereas in Illinois it's over 50%, which really cuts CO2 emissions. Using a mix in your pathway or tailoring a mix to reflect your own input data are great ways to add a level of detail and sophistication to your model. I hope you now understand mixes enough to include them next time you're building or editing a pathway. Thanks for watching.